Hello, today we will be solving puzzle number 21 in cracking the Cryptic called Killer Arrow Sudoku. Now I have already solved this once before just to see how difficult it was, so this will be more of a little guide to how to solve this one instead of a full solving of myself. So let's just get cracking at it. So this Sudoku contains classic rules, of course, and then we have the killer rules, which means that the number in the top left of the cell is the sum of the digits inside the cell. And arrow is basically the same as the cages. We have this little circle cell here. It could be a 3, which would mean the sum of all of these little arrows that protrude out of the circle will have the same sum. So this will be a 1, 2, this will be a 1, 2, and this will be a 3. And that's all the rules for this Sudoku. So let's just get cracking at it. So the first thing we can look at is this 15 cage. There's only one possible solution with 5 digits, which is also going to be shown over here in the little calculator. It can only be 1, 2, 3, 4, and 5. That's the minimum amount 5 digits can add up to. It's 15, so it will be the 1, 2, 3, 4, 5 pair. And down here, we also know that these can only be part of the 1, 2, 3, 4, 5 sub-rules or subset, as 3 digits can only add up to those with 1, 2, 3, 4, and 5. We also know that one of these digits in the 8 cage here has to be the 1. So there will be at least a 1 in one of these 3 cells here, because you can't add 2, 3, and 4 together. That will give 9 instead of 8. So now we know this cell at least cannot be the 1 in the entire 1, 2, 3, 4, 5 cage. And we also know this one cannot be a 2, since, let's say, this field here is going to be a 2. We'll need these 3 cells to add up to 8, which you can see over here. There's only one solution with where the 2 does not exist in it. It's 1, 2, 3, 4. If these 4 fields are 1, 2, 3, 4, that means this little arrow down here needs to be a 5 and a 6, which adds up to 11, which is not possible in a single cell arrow. So now we also know it's gonna be a 2. Same goes for the 3. If there's not a 3 in this cage over here, you can see it will be 1, 2, 5. If these are 1, 2, 5, so 1, 2, 3, 4. 1, 2, 3, and 5. We will have 4 and 6 here, which gives 10, which is also more than a single cell. So this one can also not be a 3. Let's get back to this little cage here. Since we know this cage here needs to have the 1, then we can look at this little arrow up here. We know it cannot contain a 1, so the minimum sum of these ones will be 5, which is 2, 3. And we can extend this one up to, so it will be at minimum 5 and maximum can be 9, because there's only a single circle here. So we know this one is 5, 6, 7, 8, or 9. We also know it cannot be the 5 actually. If these 2 are 2, 3 pair, what does it do to this cage down here? It cannot have a 2, so this one will be gone. It cannot have 3, so this one will be gone. So now we don't have any solutions for that one. So we know this is not a 5. Now it's 6, 7, 8, or 9. It can also not be the 6. Because if this is a 6, we'll have a 2, 4 pair up here. It will have the same constraint as before with 3. Now we have the 4 over here. So there's no possible solutions with a 2, 4 up here and a 1, 3, 5 down here. That'll give up to 9 instead. So now we know this is a 7, 8, or 9. Yeah. Now the next thing we can look at is this little arrow over here, which is very interesting. Let's just color this one in red. And we know the arrow points down to this cell down here, so this will have the same sum. So it will be the exact same digit up here. Now let's look at cage 2 here, where can the red be? It cannot be in this row here, on this column here, so it will be one of these 4 fields up here. We know there will be a red in any of these 4 fields. But now let's think about what would happen if we put the red in this cage up here. So let's say the red is in this cage up here. Let's just remove the coloring here. Now, where will the red be? In box 8 down here. We know it's not in this column because we already have the digit here. We know it's not in this column over here because there's red, so it can only be in this column over here, where we know it will be from one of the digits 1, 2, 3, and 4, and 5. So let's say it is in this cage. If this is 1, 2, 3, 4, 5, we know we need at least 2 digits to add up to the sum, so it cannot be 1 and 2. So now it's a 3, 4, and 5. We also know it needs to be in this cage that adds up to 10, so it cannot be a 5, because it doesn't mean there will be 2 5s in this cage. So now it's a 3 or 4. We can also look at this little circle over here. If the red is in this cage, where would we put the orange digit then? It cannot be in any of these cells. And we also know it cannot be on the arrow, because this is a 7, it's obviously way more than a 3 or a 4. So it also needs to be in the box over here. So now we know this would be a orange, the orange digit and the red digit. And we know both needs to add up to 10. So now if we add the orange digit and the red digit, they should add up to 10. We know it has to be a 7 and a 3. That's the only that's the only combination that adds up to 10. But now let's see. This one, this arrow here needs to add up to 3. So it needs to be a 1 and a 2. We have a 3 and 7 here. How do we get 7 in this arrow now? We don't have 1, 2, 3. So this will be minimum 4 and 5. That's 9, which is more than 7. So now let's backtrack quite a bit. All of this is because the red digit was in this cage here. So now we know this can never be a possible solution where the red digit is part of this cage. So we know the red digit is going to be part of the arrow over here that adds up to, let's make this one orange again. So we know this one will be 2, 3, 4, 5, 6, 7. Of course it's not a 2 because we cannot add 2 digits up to 2. But at least now we know it's lower than the orange digit, and it needs to be on the orange digits arrow here. We can also just write in this one. Now let's have a look at where the orange digit goes in this box 2 here. It can obviously not go in any of these digits, as they're already seen by normal Sudoku rules. We also know it cannot go on the red arrow, because a digit on the orange arrow needs to be lower than the orange digit, but the orange digit cannot be lower than the red digit at the same time. That's impossible. So we know the orange digit is somewhere in this little box here. And we also know down in this box, down here, box 4, where should the orange digit be? It has the same constraint as before. It cannot be in any of these cells over here, so it needs to be in one of these cells here. But now let's think about what happens if this digit is 9. If this digit is 9, that means it can never be on this arrow down here, which means it needs to be in both of the 10 boxes here, which means they are 1 9 pairs. And now it leads to this little 15 box to be impossible. Because now we have the 1 cannot be in this column, and the 1 cannot be in this row. So there can never be a 1 in any of these digits here, because these two are the same digits. So now no, this one up here can never be a 9. And we also know it can never be in the 10 box here, because no matter what we put in here, if this is A2, this is A2, it's gonna have the exact same digits, and that will mean there's no possible solution for the middle 15 box here. We can do the same if it was 3, 7. The 3 cannot be in any of the digits in the 15 box. So we know it's never gonna be in the same box here. And it's never gonna be a 9. So this is 7, 8. Which also means that down here in this arrow, let's just color this one green. We know it contains 7 or 8, which means this already needs to be higher than a 7 or 8, which means it's a 8 or 9. This one is also going to be 8 or 9. And we know adding 2 digits with a 7 or 8 to 8 or 9, it needs a 1 or 2 at least. So now we also know that because we have deduced that this little arrow cannot be a 9, we cannot have a 7 here, there cannot be a 7 in the red digits anymore here. So this one will be a 1, 2, 3, 4, or 5 digit, since it needs to add up to a maximum of 6. We also know the orange digit is gonna be in this 10 box here. It has to be a 7 or 8. Look over here, it's 2, 8 or 3, 7. So notice 2, 3, 7, 8. And now let's see what happens with these 2 digits. When you try to, for example, make this one into a 3, we'll have a 1, 2 here. We know this one cannot be a 7 now, because if this is a 7, we would need the red 3 to be in the same box over here, so this one will be an 8. So now we know this will be a 3 and 5. Is that possible with the 8 box down here? Sees both 3 and a 5? No, that's not possible. We cannot add it up to 8 with 1, 2, 4, that's 7. So now we know this one is not 3 at least. We can do the same with the 4. So now we have 4 is gonna be over in one of these digits. Again, we know the 3 is already taken from this arrow now. So there cannot be a 3 in here. This will be a 2 and 8, which means this one will be an 8, but with a 4. Adding up to 8 with a 4, and a second digit should also be a 4. But that's not possible by normal Sudoku rules. This one will not be a 4 either. Now let's try with a 5 maybe. A 5 over here. This one contains a 5 and a 2 or a 3. So now we know there's going to be a 2 or a 3 here. 2 or 3 here. This one cannot contain 2 or 3, so this will be 1 and 4. And from a quick scan, this seems fine. This one will be 1, 3, 4, so this one will be 7. This will be 3, 7 over here. So this one looks doable for now. So this is a solution, at least, with the 5. Now let's have a look at the 6. This is 6. We know The minimum of these two digits add up to 8. So this one will be an 8. But now let's look at this tin box again. We know it contains the 8, now it also needs the 2, but the 2 is already taken from the arrow, so this is not a possible solution. So now we know this digit can only be the number 5. And now let's just add in these digits we had before. This one is taking the 5 down here, so it's 1, 3, 4. This one is a 7, and this one is gonna be a 3, 7. Let's just remove these color rings again. Now this digit down here cannot be a 4 anymore. This one will be a 5, so now we can remove all the 5s from the box over here. And the remaining digits in box 2 is gonna be 6, 8, and 9. Now we also know that before we had the orange digit, which was the 7 cell up here, needs to be in one of these two digits on the arrow, so it's 1, 2, or 7 now. Now let's have a look at this little arrow down here. We know it cannot be 1, 3, 4, or 5. So this one will be a 2, 6, or 7. That's the maximum it can be. 2 and 7 together. It's gonna be 9, 2 and 6, gonna be 8. So we know the maximum, or the minimum at least, it's gonna be 8 and 9, which is also the maximum digit it can be. We also know that this one contains at least the 2 somewhere in the arrow. Otherwise we cannot have 6 and 7 added together. Now we also know that the 3 from up here sees these 2 fields here. So the 3 needs to go in any of these 2 fields. And now let's have a look at this little cell here. Where can it be in box 4? Cannot be in any of these cells by normal Sudoku rules, and it cannot be in the arrow, similar to before, because 8 and 9 is higher than 7, so it needs to be in one of these 2 fields. It's gonna be 1, 2, 8, and 9, because that's the digits that add up to 10. Now we can also see these 2 digits up here. We know there's gonna be a 1 or 2 on this arrow. We know there's gonna be a 1 or 2 in this box, so both the 1 and the 2 is already taken. This one will need to be a 3 or 4, or it will need to be 3 and 4, exactly. And where are we gonna go from here? Where are we gonna go from here? I guess this digit right here. We know there's gonna be a 1 or 2 in any of these 2 fields here. And we know it's gonna be these 3, 4 cells are gonna be 1, 2, 3, and 4. So let's say this one is a 4. It's gonna be a 1, 2, 3 up here, which means there cannot be a 1 or 2 here. So this one will never be a 4 down here. This will always be a 1 or 2. And now we can also see we have already taken 1, 2, and 7 here, so they cannot exist anywhere. Anywhere in this row. And we also know this one up here cannot be either 1 or 2 over here, and then the remaining 1 or 2 and 3 and 4. So this one will always be a 5, 6, 7, or 8. Cannot be a 9, just by arrow rules, because this one can maximum add up to 9. Down here we know it cannot be a 1 or 2, so this one will be minimum of 3 and a maximum of 4, because 4 and the minimum up here is 5. It's adding up to 9. So now we also know this one cannot be a 7 or an 8, because that will add up to too much. So this one is now also an 8 or a 9. Now let's have a look at box 8 here. Where can the 8 and the 9 be in this box? We know it cannot be in any of these fields already. And these are already seeing, this little cell up here already sees the 2 8 and 9s. So they need to be in exactly these two cells. Which also means this one up here is gonna be from the remaining 2 6 7. We know the 2 is already on the arrow, so this one needs to be a 6 or 7. This one cannot be a 1 or a 4, so this one is a 2 or 3. Now let's have a look at these 8 and 9s. Let's just call this one red, this one orange. No, this one is gonna be the red one, because it cannot be the orange one. This one is the orange, this one is the red. And we know in box 2, where's the red 8 9 gonna be? It can only be in this cell up here. This one is gonna be the red one. We also know in this box 4 here, the red was in one of those two fields. So now we know the red 8 9 is gonna be in one of these 3 fields. Cannot be in this one, just based on this digit. It's gonna be in one of those two fields. Now let's have a look at this 14 cage. You can see over here, it can only be 5, 6, 8 or 9. We already have the 2 8 9s here. This one can only be a 5 and 6, which means this one is gonna be the 8 or 9. Already sees the red one. So this is gonna be the orange red or 9. Now let's have a look at this box 3 up here. Red 8 or 9. Cannot go in any of these fields by Sudoku rules. Cannot be in the 7 cage, because that's up to too much. So it's one of these two fields up here. Now let's have a look at the orange one, maybe. Maybe not. Let's write in these digits. I guess we know they cannot be the 1 and the 2. 7 down here, 3 and 4. So this will be 5, 6, 8 or 9. Together with this 8 and 9 over here. And also for these digits here, 5, 6, 7, 8, 9. So know the remaining digits always gonna be 1, 2, 3 and 4. Same down here, 1, 2, 3 and 4. As the remaining digit in the column and in the row. This one up here, 5, 6, 8 and 9. So now we have this quadruple 5, 6, 8 and 9. There can never be 8 or 9 here, so the red digit is not gonna be here. No, the red digit is gonna be in this one. And what more? Maybe we can already place the red 8 and 9 up in box 1. These are already taken by this one. And this one is seeing the red 8 9 from this column. So it will always be up here. This one is the 8 9. This one is going to be the 5 6 one. Because it sees the other 8 9. And the orange red or orange 8 9 maybe here in box 6, where can it go? It cannot go in any of these 3 cells, because it already has the red 8, 9. If you add 8 and 9 together, it will be 17, which is more than 16. It's already seeing those fields, so it will be in one of these 2 fields over here. I feel like this 18 cage is gonna be a bit interesting. We can also just this digit here maybe. We know it cannot be 1, 2, 3, 4, 5, not a 7, so this 6, 8, and 9. Now we have this little quadruple again. 5, 6, 8, and 9. We cannot have the orange 8 and 9 here. It will be in this cell here. And now in box 3, orange 8, 9. Not in these cells. Not in the 1, 2, 3, 4. Not in the 7 cage. It will be in this cell up here, which means this one is the red 8, 9. Which means this one is gonna be the red 8, 9 down in box 6. Now we can also place the orange 8, 9 up here. It's already seeing these 2. This one is now a 5, 6 pair. This one cannot be a 5 anymore. It's a 2, it's a 5. Very nice. What else? This one cannot be an 8, 9 anymore. It sees both of them. Let's have a look at the 7 in box 3. Cannot be in the cage, obviously. So it needs to be in one of these 2 cells up here. Which means it needs to be in one of these 5 cells. This one already contains a 5, just based on normal Sudoku rules. We can also have a look over in the nice little calculator. We can just remove a lot of the possibilities already. Cannot contain the 8 or the 9, so we can just remove all of these 8 and 9s. It needs to be, there needs to be at least a 5 in it, so we already know only 2 possible combinations for now. I feel like this 16 cage is probably gonna be interesting. Yeah, I guess maybe let's have a look at 7 in box 6 over here. We know by normal Sudoku rules it cannot be over here in these cells. We also know there needs to be a 7 down in row 6 in box 4 over here. So these cells are also taken. And we cannot have a 7 in any of these 2 cells. It needs to be... Oh, not the coloring, sorry. There we go. This cell needs to be the 7. And now we can also place the 7 down in this box down here. It cannot be in any of these 3 cells based on 7 up here, 7 here. So notice 7 is gonna be inside this 18 cage, which means it can only be the 2, 4, 5, 7 pair. So let's just write 2, 4, 5, 7. There we go. And let's remove the 7 from over here. This one is a 2, 4, 5. The remaining digits here will be 1, 3, and 6. Where does that lead us? Where does that lead us? Where are we going from this point, please? Probably back to this 16 cage maybe. I think so, yeah. Let's see here, we have these two digits here. Let's figure out what they are. We know the sum of the digits 1 to 9 is gonna be 45. And we also know the sum of all the remaining digits here, so we can figure out the sum of these two together. So let's see, 16 plus 5 is 21, plus 14 is 35. We need to add up to 45, so these two cells needs to add up to 10, which means this one will be a 1, 2, or 4. It cannot be a 4 based on these two fields. So this one is a 1 and a 2, which means this one cannot be a 6 because these needs to add up to 10. Now we also know the orange 8, 9 up here. And we can see here, now we have this little triple of 1, 2, 4. This one needs to be the 4. And this one needs to be the 3 because 1 and 2. So now we have the little orange 8, 9 in cage, or in box 5, I mean, needs to go in this cell here, which means it's gonna be a 6 up here, and this one will be the orange 8, 9. Now we know this one is gonna be the 6 because that's the last remaining digit. This one is gonna be a 7 now, which means this is gonna be a 2, 6 pair. So now we know all the red 8, 9s gonna add up to 2 and 6, which is 8, and the orange ones are gonna be 9. Let's just remove the coloring again if I did that. Oh, this one down here, also 9. This one needs to be the 9, 5 pair now, which means this one is the 6, this one is the 5. Now we know this one needs to be a 2, this is the 6. We can just remove the 2s from over here in this cage, the 5s from here, these two cells. Now we know. Let's have a look. This 5, 6 over here already sees the 6. This one is a 5, 6. This one is gonna be the 5 now. It needs to add up to 9. So this one needs to be a 4. Remove the 4s down here. We have 2, 5. This one cannot be a 2. This one cannot be a 5 anymore. Now we have this one over here. So it's the 8, needs to add up to 10. This one is a 2. This one is 1, 7, so this one needs to be 2. Send 1. Now this one already sees the 2 from the cage. This one needs to be a 1. These two cannot be a 1 anymore. This one is the 1. This is gonna be 2, 3, and 6. This one sees 2 and 6. This is 3. This one already sees the 6 from down here. This is a 2. It's a 6. Now there's 1, 2, 3. It's gonna be a 4 and a 7 pair up here. Remove the 4s over here. Cell up here. Cannot be a 1 and 2. This is a 3. Let's remove the 3s over here. What can this cage up here now be? It cannot contain 3 or 5, so it cannot be 3, 4, it cannot be 2, 5. This is 1, 6 pair. This one cannot be a 1 now, it's a 2. This one cannot be a 1, sees the 1 down here. This is a 6, this is a 1. This one sees the 1 over here now. This one sees the 4. This one sees the 7. This one sees 1, 3, and 4. This is a 2. Let's remove the 2s from all of these. 1, 4 pair down here. It's 3. 2, 3 up here. It's gonna be 1, 4 pair. Let's see. What are we missing down here? It's gonna be 1, 3, 4, and 7. This one sees the 1 and the 7. This is a 3 and 4. Now we have the pair of 3 4s. This one can only be a 1. This one is the 3 4. This one is the 3 now. This one needs to be a 6 now. None of these can be a 3 anymore. The middle one digit is a 3. This one cannot be a 1. This one cannot be a 1. This one cannot be a 4 anymore. This one cannot be a 1 anymore. And now we have 2, 6, 7. This can only be a 2. This one can only be a 7 and a 6. And there we go. That is the solution to puzzle number 21 in cracking the Cryptic.